Howdy, folks. We're going to go ahead and talk about how we can solve quadratic equations algebraically and graphically. So we have two methods for solving them. Today we're going to be looking at the methods for solving algebraically and graphically, ones that have the value b equals 0 specifically. So that means we're looking at ones that look like this. They look like ax squared plus c equals 0. That will be an equation, or y equals ax squared plus c. Either of those. So there's two ways that we can solve these equations. We can, we can do it algebraically, or we can do it graphically. So I'll do graphically first. We're going to talk about what it means. What is a solution to a quadratic equation? And then we'll do it algebraically. Okay, so just so you know, the solution to a quadratic equation is also known as a root or a zero. And really all that means, a solution, a root, or a zero is just wherever the graph crosses the x-axis. Now remember, the x-axis is the line y equals 0. It's a horizontal line, so that's why they're called zeros. It hits 0 on the y-axis. So that's our line that we're looking at. And these 2 points right here are our solutions. These are our zeros. So our two solutions are x equals 0 and x equals 4. Now I didn't give you the equation here, but it's just an example. You look at the graph, you see where it crosses the x-axis, and that is those are our solutions, our roots, or our zeros. X equals 4, x equals 0. So you tell me, what do you think the roots of this quadratic are? We will have two solutions to this equation. It would be x equals negative 0.5 and x equals negative 7.5. Now, graphically is a great way to solve quadratics if you find yourself in that situation. You could plug it into some graphing software and it'll just tell you the zeros, which is nice. There are other ways to do it too. Okay, so let's think about this. In order for us to solve 0 equals x squared minus 9 or x squared minus 9 equals 0, all we have to do is graph x squared minus 9 and then look and see where it crosses the x-axis, and those will be the solutions. So when I say solve graphically, I mean we're looking for the numbers that make this true. We're looking for the numbers that make this true. Okay, so let's think about this for a second. X squared minus 9. Well, that looks just like the parent function, but if the parent function had been shifted down 9, if that was from like 8.1 and 8.2, we talked about that. So the parent function looks like this. So I'm going to start down here at negative 9, and it's going to have the same shape as the parent function, which is over 1 up 1, over 2 up 4, and I'll reflect over 3 up 9, and we're done. Over 4 up 16. So that's 9, 10, 11, 12, 13, 14, 16. Perfect. All right, so this is the shape of my parabola, and I'm going to botch, as always, I'm going to botch connecting these dots. It's so hard on this pad. Please forgive me. I'm going to pause, and then I'm going to come back once I've got it. All right, that's about as good as it's going to get for me. So that's what it looks like. So what are our solutions? What are the numbers that make this equation true? Well, our two solutions are right here. X equals negative 3 and x equals 3. And so if I look at this equation, if I were to plug in 3, it would make the equation true. 3 squared is 9. 9 minus 9 is 0. That's a solution. Negative 3 squared is also makes the equation true. Negative 3 times negative 3 is 9, and 9 minus 9 is 0. So solving graphically. So go ahead and give it a shot. I believe you can do this on your own. Try and graph this and tell me what you think the solutions are. Pause the video if you need. Okay, so what does this graph look like? So to solve this, we're going to graph the equation y equals negative x squared plus 4, and we're going to see where it crosses the x-axis. All right, so that looks like the parent function, but flipped upside down and shifted up 4. So I'm going to start here at 4 on the y-axis. I'm going to go over 1, down 1. I'm going to go over 2, down 4, and there we go. We're done. Now I'm going to keep going just for kicks and giggles. So over 3, down 9, and we'll call that good enough. So this is my graph. Oh, geez. It's going to work. It's it. That's it. We're good. It's good enough for me. Okay. And there are our 2 solutions. There are 2 numbers that make this equation true. 2 solutions. X equals -2 and x equals 2. Fantastic. All right, so how do we do this algebraically? It's really quite simple. I'd like to remind you of something that we discussed during, solving linear equations. When we were first solving linear equations, I say, hey, there's this table of mathematical inverses or inverse operations. Mathematical inverses. They are operations that undo each other. And we said the opposite of adding is subtracting. If you have 10, apples and you add 6 and then subtract 6, you're back to where you started with. Adding 6 and subtracting 6 undo each other. Okay, if you multiply and then divide, those undo each other. Okay, well, it turns out there's another inverse that we're going to need. So this asks the question, what number times itself equals 121? So if you can answer that question, you might say, well, x equals 11. 11 times 11 is 121, but it turns out there's another number as well. Remember, these parabolas crossed at 2 locations. X equals -11 is also a solution because it is a number that also makes this equation true. So how do we see that in our table of inverse operations? Well, it turns out that when you take a number and you square it and then square root it, those operations undo each other. Now remember, a square root is something to the 1/2 power. So here's the example. 6 squared to the 1/2 power. These things undo each other. We multiply the powers. We end up with 6 to the 2 times 1/2, which is 6 to the 1st. So it's just 6. So squaring and square rooting undo each other. So this is how you should show your work here. What we actually do, since we have a square, is we take the square root of both sides of the equation, like so. Okay, and what you end up with is x is equal to plus or minus whatever the square root of 121 is. So it's the positive 11 and negative 11. We have 2 solutions. Cool. All right, I'm going to do about 1,000 of these. Feel free to pause the video at any time. I'm not going to stop. I want you to see all the kind of different variations and the strategies for solving. All right, so this one is not, in the same orientation as the previous. The other one had the constant on the other side already. If we want to solve this algebraically, we could graph x squared minus 36, but I don't really want to go down 36 on a graph. That doesn't sound like fun. So what I'm going to do is I want to try and get x squared by itself. So I'm going to add 36 to both sides of the equation. And I'm left with this thing, or this step that says, what number times itself is 36? Well, you guys probably know that's 6. But you need to remember that you have a positive and a negative solution to consider. So you square root both sides and you'll get x is equal to plus and minus the square root of 36, which is plus and minus 6. So we have 2 solutions, x equals 6 and x equals -6. And I'd like you to write them like this so that you really understand you have 2 solutions. This is just kind of a shortcut way to write 2. Many people don't understand that this is actually 2 solutions and not 1. So please write them like the way I've written them in the box here. Okay, in green, we have a couple ways that we can talk about solving this. You could subtract 12 from both sides, but then you'd have to divide by -1. So what I'm actually going to do to get this positive is I'm going to add x squared to both sides. And what you end up with here is 12 is equal to x squared. I'm going to use the property, the symmetric property, and I'm going to flip that around. So you get x squared equals 12. What number times itself is equal to 12? Well, there isn't a number that is a perfect square, like all the previous examples that we had. So let's go ahead and get out our calculators, and we're going to use that inverse operation. What number times itself is equal to 12? Well, we're going to take the square root of both sides of the equation here, and we're going to end up with x is equal to, okay, pull this up, 3.46. It's about, squiggly equal, it's about equal to plus or minus 3.46. So we have two solutions. X equals 3.46, and the second one is x equals negative 3.46. Cool. So if I were to graph these, that's where they would cross the x-axis. Pretty exciting. We're going to keep cruising. I got 4 more here. Let's go ahead and jump right in. So again, we want to get that squared term by itself. I bet you guys can do this one in blue. So give this one a shot. You want to get the squared term by itself and then take the square root. Here we go. Minus 13 minus 13. So we'll end up with x squared equals 29 minus 13 is 16. What number times itself is 16? Well, that's going to be x equals 4, and x equals negative 4 if we take the square root. Square root of 16 is 4. Let's do the red one next. This one's great. All right, I want to get y squared by itself, which means I need to move the constant over to the other side, just like we were solving in linear equations. We'll end up with negative 2y squared is equal to negative 8. Now, to get y squared by itself, we're multiplying y squared by negative 2. What undoes multiplication by 2? That would be division by negative 2, right? So I should say, I think I said multiplication by negative 2 is division by negative 2. All right, so negative 2 divided by negative 2 is 1. So we'll get 1y squared is equal to negative 8 divided by negative 2, which is positive 4. And that's, again, a nice perfect square, and we'll get two solutions. What number times itself is 4? That's going to be y equals 2. Y equals negative 2, and that comes again from taking the square root of 4. In green, this is an interesting one. Whoops, I forgot to box my answer. Enough to drive some people crazy if I skipped that step. Okay, over here in green, let's take a look. I'm going to shrink this up so we can get a good view. Again, same kind of steps here. You know, we're going to subtract 86 from both sides. You'll notice an interesting thing happens. We end up with 4z squared is equal to 0. All right, well, we want to get z squared by itself, so we can divide both sides by 4. Like that. 4 divided by 4 is 1, so we'll get z squared. 0 divided by 4 is 0. What number times itself is 0? Well, some people would say positive 0 and negative 0, but there's no such thing as negative 0. It's just 0. So here we only have one solution, and it's 0. Fantastic. Yeah, so there are situations in which you'll get two solutions, and there are situations in which you'll get one solution. Let's go back down. Sorry, I pressed the wrong button. Spoiler alert. Spoiler alert. Okay, this one is a little bit different. That's okay. Almost the same. We're going to add 13 to both sides. We're going to divide by 3, so we'll get a squared is equal to 13 divided by 3. You go to your calculators. 13 divided by 3 is a squared equals 4.3 repeating. All right, so how do we get the answer here? What are we going to do to both sides? We are going to take the square root. I skipped that on these previous steps. I should have added that square root step in here, but I did it on the first two. That's fine. 4.3 repeating. All right, and we're going to get two solutions. So I'm going to go to my calculator and take the square root of this value. The square root of 4.3333333. And we get a is equal to, we're going to get two solutions. 2.08, or is approximately equal to 2.08, and a is approximately equal to negative 2.08. So these are the numbers that make that equation true. If I were to take 4 and plug it into this equation, you'd get 4 squared is 16, 16 plus 13 is 29. It makes the equation true. Perfect. All right, I do want to offer a little bit of a warning. Let's offer a little bit of a warning here. X squared plus 100. Let's go ahead and solve this. All right, I'm going to subtract 100 from each side. What we end up with is x squared is equal to negative 100. All right, so before you write plus or minus 10, what number times itself is equal to negative 100? 10 times 10 is positive 100, and negative 10 times negative 10 is also positive 100. It is impossible to take two real numbers, something that we're used to working with, multiply them together and get a negative number. It can't happen. So what does that mean for us? What does that mean for us? That means there is no real solution. So we can say no real solution when you find yourself in this situation. When it's asking you to take the square root of a negative number, by the way, if you go to your calculator and try and do the square root of a negative number, your calculator is probably not going to like it, or it might spit back like an I or something weird that you're not used to seeing. So there is no real solution. You might also see something that says no real roots or no real zeros. Super. So that's how you respond when you find yourself in this situation. X squared is equal to negative 100. Okay, I want to talk about these for a couple seconds, really quickly. Let me go to Desmos. And remember how I said the solution to these equations are where the quadratic crosses the x-axis? Just a sec. All right, so what I've done is I've taken y equals x squared plus 100 and I've plugged it into Desmos. Now remember your solutions, your roots, your zeros are where the graph crosses the x-axis. And if we look at this graph, we can see that it doesn't cross the x-axis, and that should be kind of apparent. If you look at our equation, it has a y-intercept of 100, and it's opening up, which means it's way, way up high, and it's opening up, so it's not even the two sides of our parabola are not even going towards the x-axis. So no wonder it doesn't cross the x-axis. No wonder we have no real solution. So let's try one of the ones that does have a solution, like this one in purple. 3a squared minus 13. I'll just do 3x squared minus 13. When I take a look there, let's zoom in. Now remember, it should cross the x-axis at 2.08 and negative 2.08. Let's make sure. Hey, look at that. 2.082, negative 2.08. Great, fantastic. Okay, and how about this one? This one, when we get it kind of in this standard form, everything on the left side equal to 0, we end up with 4x squared. And 4x squared only crosses the x-axis at one point. It just touches it like this. Okay, so it only crosses at one point, which means it's only going to have one solution, which is x equals 0. I used x instead of z. It doesn't really matter. You can substitute that in no matter what letter is in your equation. Yeah, perfect. Okay, great. So in order for us to really plug it into Desmos, though, and check our solutions, you need to have it in standard form, which means you need everything on the left side of the equation. Everything should be on the left side of the equation. So that's why you would need to move things around in order to get it to work. So this one would have ended up being, we would have had to subtract 29 from both sides. It'd be x squared minus 16 equals 0, so on and so forth. Okay, great. Okay, so let's take a look at this last one. We're going to do it algebraically, and I think we'll check it graphically. I want you guys to try on your own, and then we'll take a look and do kind of a little summation deal in the end. So let's take a look at this graphically. All right, so let's go ahead and do it algebraically first. So algebraically, I want to solve for x squared, which means I want to get x squared by itself. I should get the constant on the other side, so I'm going to add 7 to both sides. That'll be 1/2 x squared equals 7. Okay, and then to get x squared by itself, I'm going to divide by 0.5. And when you divide by a half, it's the same as multiplying by 2, which will give us x squared equals 14. And then we will get two answers. One of them is going to be the square root of 14. One of them is going to be whatever the negative version of the square root of 14 is. And we'll have to kind of round that out. So that's going to be 3.74. So 3.74 is one of our options, and negative 3.74. And we're going to do this graphically as well. So what is this? If we graph the equation y equals 1/2 x squared minus 7, what does that look like? Well, it's got a y-intercept of negative 7, and it's opening up. It's shaped like the parent function, except everything has been compressed, or has been divided by 2 in reference to the vertex. So normally with the parent function, I would go over 1 and up 1 if it was y equals x squared. I'd be starting up here, but everything has been shifted down 7, right? I'm not going to go over 1, up 1. I'm going to go over 1, up 1/2. I'm going up half the height that I normally would, and I can reflect that point. Normally with the parent function, I'd go over 2 and up 4. I'm not going to go up 4. I'm going to go up half that amount, which is 2, and I'm going to reflect that point. Normally when I go over 3 with the parent function, I go up 9. I'm not going to go up 9. I'm going to go up half that, which is 4.5. Reflect. And normally with the parent function, when I go over 4, I would go up 16, because 4 squared is 16, but I'm not going to go up 16. I'm going to go up half that, which is 8, which puts me right here. So that's enough for us to see that our two solutions hold true. You can see as this curves up and heads off into these really large numbers on the y-axis, we can see that our graph crosses just before 4. That's where that would be our solutions right here. There is our 3.74. That does not look like 3.74. There's our 3.74 and our negative 3.74, and it would look better if I was better at graphing. All right, so let's take a look. Quadratic equations can have two solutions. They would be like quadratics that look like this. They cross at two locations, and it could be in either location. I just drew those arbitrarily. They could have two solutions. They could have one solution, so they could maybe come down and touch at one single point. So this is what two solutions would look like. It crosses at two spots, or maybe like this. That's also fine. And quadratics can have zero solutions, which means they don't cross the x-axis. That would be like in this situation or in this situation. All right, so hopefully you guys kind of understand the link between solving a quadratic equation and graphing a quadratic equation. Now, if you want to check or do that, make sure you put your quadratic equation put everything on the left side. So, for example, if the equation says like 3x squared plus 8 equals 10, right? If you want to try and figure out where this crosses the x-axis, you need to get everything on the left side, which is called standard form. So you'd write this as 3x squared minus 2 equals 0. You graph that, and that'll give you your solutions. If we were solving it algebraically, however, I wouldn't do that necessarily. I'd isolate x squared, so I would subtract 8 from each side like this. You get 3x squared equals 2, divide by 3, and then go from there. Okay. All right. Thanks for paying attention, and thanks for checking out the Mathnasium. We'll see you next time.